Welcome back my channel. Today now we are going to talk about the type of force and action. Type of force and action. We discussed different type of force and action in the course dealing with properties of material. A basic understanding of the different type of force allows us to appreciate that the structure are made of members in tension and compression, and beam, plate, elements, shells, each connected in held in the place appropriately. It is important to think of the structure acting and how it determine and depend on the position and connection between its constituents element for equilibrium and stability. First, we have discussed the loads. We have mentioned various loads that act on a structure. Let us discuss how these loads arise and some basic classification. In analyzing or designing a structure, we have to distinguish between static and dynamic load. Static loads refer to usually the static load refer to load that are slowly applied to a structure, or those which are steady state, constantly acting on it. As static loads, the deformation caused by such a force would also develop slowly and be largest when the static force is a maximum. Static load are caused by dead load, live load, and force due to settlement or the thermal effect. Dynamic loads are those that are applied suddenly to a structure. They may vary rapidly in magnitude, direction, and location. The deformation case may also vary rapidly and not synchronized with the disturbing force. So when we consider the load, usually the loads are gravity load. This is a gravity load. And therefore act vertically downward. Usually this act vertically downward on a structure. These loads comprise the self-weight of the structure and all the finishes, immovable fitting, walls, roof weight, and its magnitude of these loads may be estimated quite accurately, but only if the occupier or user does not change the requirement and load agreed for the design. Uncertainty could also be caused by construction, the dimensions constructed not being those designed. The one is the imposed load or live load. This load are different from the dead load because they may or may not be acting on the structure at a particular instant. The weight of the occupant, furniture and equipment are considered as gradually applied. A vertical imposed load. These act on the structure due to occupancy or use and are movable. Therefore, the point application is not fixed. Hence, we have to consider the various possible arrangement of live load and consider the most adverse combination for design purposes. For example, the live load may be imposed on the whole floor or only some portions of the floor and not on others. The floor has to be capable of sustaining the worst effect possible from a realistic arrangement. The snow load on roof is also considered as imposed load, since it does not act all the time and the pattern of loading may vary. Live loads may also be horizontally. For example, the push-over force put productive barrier in balconies, catwalks, bridge, garage, and car park need to take up would generally be applied horizontally. Other one, wind load and earthquake load. Wind load and earthquake loads are considered separately due to the dynamic aspect. The load caused by wind is not a steady static load due to the gusting of the wind. This is signification on roof on other cladding and less on the larger components such as the frame of a large building where the dynamic effect will not be critical. The wind load considered in analysis in design are the empirically determine equivalent static load. Wind may cause tall building to sway and produce a dynamic response reason in tall building. In bridge and flexible structure, there have been failures or bridge such as the Tacoma Narrow Bridge caused by the dynamic response to wind. Hence, the designer has to make an informed decision as to when the dynamic nature of load need to be taken into account. When we consider earthquake as load propagated in the form of waves that cause the earth's surface and any building founded on it to vibrate. Earthquake load have generally not been considered for the design of non-high-rise building in this country. The consequence of accident, damage, or explosions need to be taken into account in the design of any sustainable building. Escape route and safely drill have to be designed in and become critical. As buildings get larger and taller, bridges are subjected to moving loading from various type of vehicle. The equivalent static effect are considered for the initial design, but the dynamic effect including those due to wind, earthquake and other effects need to be taken into account for the complete design.